to breath limit. What the fuck? 傻笑。Okay, interesting. What? Okay, the network is very slow. Is it right? Interesting. Oh my god. Okay. Oh, okay. So this part runs to parasitic string is non-empty string consists of the left, right is valid if any of the following condition is true. It is so it's the will form parasitic valid parasitic. Okay. So AVA is concat, or we can say right recursive bit. So what I want to do is, you given about this, you want to find the matrix. So the path start from upper, and from this, you want to move the down right. So if you see is valid in the string, always say return false. Okay. My idea is that so what we want to do is starting from first to find a valid path starting from 0, 0, 2 and -1 and -1. Okay, this is our goal, right? So yeah, we're gonna say if occurrence right parasitic, we never reach this, right? Because yeah, so what's the idea? Consider we have a score here. I want to use dynamic programming to do that. Dynamic programming, we have the current position and we have the close. Actually, the close will up to -1, right? Times n. Okay. So for each, let's just try to check that if this is valid or not. So we can use the code, means the code is the score of the parasitic. Okay, and cost is much greater than 0, right? So we have the Boolean score. We have score. We always say cost. And what I want to do is, okay, we have the DP here. Vector. DP here, and now the DP is going to be vector. Oh my god, type error. Oh damn. We have the MN. So we have grid size, grid 0 size. Okay, we also have we have then in the last dimension and product, because the codes will always be agreed. This is can reach IJUs or not, right? So yeah. Okay, what should we do here? Now we have a grid. Okay. So starting from 0, and current score is 0. Okay, we'll try to do is if I is return n minus 1 and j is equal to minus 1, return last score should be 0 because this is the valid parenthesis, right? And if I is greater than n or j is greater than 1, return false, right? Now let's try to do to find the resource is going to be dp score is going to be false, and it is false. Okay, let's try the full direction. In okay, so it's I plus 1. Okay, score we will add wait a moment. So we first add score. If score is more than 0, it still is false. Right now we just try to do this current score is that. Okay, so it's 0, 0 equal to that. We will say 1, otherwise negative 1. That's the idea. This is the initial score here. Now we have the left is 1, right is negative 1. Okay. And then we just try to do is let's just add a score. Okay. Minus 1 j minus 1. Now we say if n is greater than 0, and now let's try to do that. Is resource is over DFS. Say 9j and score at about this. Okay, if the current position is going to be right, so that's the idea. Time complexity will be the mn per diamond. That's the idea. Wait. Oh my. Oh wait. This the website's dead. Oh my god. Hey. Wait. I cannot do any problem because slow website is okay. Interesting. Let me just see the problem. In order to add the actor, press the keys digit I times here. So at I is the position of the later key. For example, at later S, we'll see that S is going to be A, B, C, D, F, G, I, S is 7 4 times. Similarly, at later case, enterprise 5 twice. Okay, so what it means the digit I times plus the keys corresponds to the digits I times here plus the 7 4 times. Why is 4 times? In order to add precision of the later of the key, precision of the later. Oh, I got idea. So this is 4, S is 4, K is going to be 2. Okay, I got idea. So do the error transition. Can I receive? It's going to be, for example, at the send message we see 226622. Given a string, the pass key represent and received by bar, total number of password tag can be sent. Multiple power 10, 10 power 9 at 7. So what is string length is going to be very big, right? You also want to do is to find the value, right? That's the initial setting here. So the goal is to calculate the number of the different distinct string can be built, right? Actually, is the problem. So if for digit 0 and 1, we don't use this. Okay. So a digit will be 0 and 1, only 2 and 9. Okay. So we don't have 0 and 1. So what I want to do is means 2 we will have Alice can be send is going to be A 6 Y 6 is M A. Wait, I don't understand that. Oh, okay. So this is a dynamic program problem, I think. Means that the digits is always be continuous, right? We just calculate a continuous digit to see if this is less than. So yeah, what I try to do is okay. So I have a dynamic programming after dp is the numbers of it so far. So idea is that is the number of ways so far. Okay, numbers of ways so far. What is the transition here? You also have a mapping here. Set to 2 will have at most 3, right? At most 3. So we have an ABC here. So you have an ABC here. So 1 2 3, 1 2 3, right? So in order to find, we just say, okay, what is the numbers of the time I can press? So we have a digit going to be number that can pass. So means that, what the meaning? So we say digit count, 0 is going to be 0 because we never choose this, right? So 1 we're going to be 3. 1 to 6 is going to be 3. 1, 6. It's going to be 3 because we can do 3 times, right? So yeah. And 8 and 9, 7 is going to be 4, 9 is going to be 4, 8 is going to be 4, okay? So 7 can be 4, 7 can be 4, 9 can be 4, this is 8. So, okay, wait, let's see this. Okay, 8. 7, 9 is going to be 4. 8 is going to be 3. That's problem. So also we have the DP here. Now we're going to try to do that. It's going to be the transition is going to be for each position, and just think about the digit here. Okay, now what I try to do is we have okay, now it's going to be press keys size. Also we have the string that is going to be the press key. Now let's return the DFS starting from 0. Okay, now that define the transition is going to be, the transition is very simple because it can be like, we just check that the DPI can going to be if we have the length, we can going to be the next position, right? So we calculate the length that can have, okay, that can have, and we can move to dp I plus length. Now let's try to do that. Okay, so what is maximum length? It's going to be the digit count. Okay, length is up. Length maximum is digit count, right? Yeah. So if I is greater, return 1. Okay, now let's try there. And time complexity is linear. Still have the resource. It's going to be DPI. Okay, now we have setting the DP here. Okay. Yeah. Okay, now let's try to do, we calculate that the current digit is going to be minus about 0. We check that the digit here, and we calculate that how many number is going to be. Okay, so the length max is going to be digit count here. Now we just say okay, so if okay, we must process this, right? So we say if say for I j in the 1j is smaller than length maximal, because we can maximize this is going to be 3. It's going to be, if this is 3, you can plus 3 times here. So okay, now we just try to think if the value string ij is going to be j plus I plus j, I plus length is going to be the digit, which means users will at the bottom. We can skip by 1. Okay, skip by 1. Else we will break. I want to use long value. Okay, make sure this will not be overflow. I think this will not be overflow here. Let's say if the digit is going to be 0 here. Okay, now we'll just try to do plus about j plus 1, because we know that if it's 0, which is going to be the digit, right? So is this is the 2, let's just say, okay, we have a 3 2, right? So we add length max is going to be 3, we will do until the 2. That's the idea, right? Yeah. What? Wait. The website is dead. It's dead. Nobody has submit. Oh my god, that's fucking so. The website is dead. Okay, now the problem is count node equal to average over subtree. Here, give it a root, return the numbers where the value is equal to average of the values in the subtree, means that sum the node divide and run down the nearest number. Okay, so now we find that where the value of a node is equal to the average of value in its subtree. What it means? Average value. For example, say this for root with value 4, the average of subtree is going to be this total sum and multiple by 6. Oh, okay, I got the idea. So we need to calculate the numbers of a node, and we will return the current sum here, and the score is to calculate the number of node that the value is equal to subtree average. Right side here is post order DFS. Okay, should we do? That's just going to be 0 answers. Now let's just try to do that. Okay, we have DFS here. Now say I want to use num function. We will return two value. First is the node sum. Second is the count here. So we will return that pair. Current is the sum and the number of nodes. So 0, 0. Let's try to do that. It's going to be we have left is going to be self. So we will return left first, add value left, right first, add value loot value because this numbers no here. Yeah. So if this song is going to be left, second, add value right, second, we'll set average. You need to care for that. So if average is going to be the loot value, so now suppose we have one node here, subtree of this node is going to be, oh okay, we still have this value. So for efficient to do that, we can say this is going to be the sum and this is going to be the number. Yeah, that's the idea. Okay. Yeah, that's the idea. Oh, pending. Okay, nice. So we have the node with a 4. Oh wait, this number, this is sum. Does it work? Wait, too slow. Oh my god, okay. Allow the trees and digit numbers in string we represent numbers good meet the constraint is going to be. So the subtree numbers then is constantly one maximum number is good int digit that is empty or empty. Okay, and then integer number. Let me be the number or a good number. So a substring is continuous. Largest string is string. Okay. I got the idea. So we will set string resource is going to be empty. This is very simple. We just simulate it. Okay, for number I is equal to number I plus 1 and number I plus 1 is equal to number I plus 2. That means we answer is going to be the maximum. Okay. String 3 number I. Very simple. Oh my god, here. Actually, we don't almost son. So yeah, we don't have this. Okay, is this workable? Yeah, seems like that's workable. Okay. Let's accept. Okay. Too slow. Okay, now we have this. Oh, down right. Oh wait, I forgot only move the down right. So we only have two moving. It's going to be this. Yeah. Wait, too slow. It's going to be. For the make pair, I forgot that. Okay, true and false. Actually, I think this should be correct. Okay, so this is timing programming, and I forgot to look about only going to be done right. Yeah, time complexity is going to be actually I think it's going to be m product and product score, and transition only 2. So yeah, this okay. I want to eat breakfast. Oh my god, too slow. Okay, I think this will be unrated. This context will be unrated. Yeah. Okay, let's just go through the 4th problem. Now this first problem. What's the first problem is very simple. It's just like, okay, you want to find the largest 3-cent digit, 3-cent number string. The 3-cent digit number in string is going to be, there's a substring, and the number with the length 3 only consists of one unique digit, and you want to find the maximum, the good integer. Actually, leading rule is as a good integer, so we just check for each length 3 substring. We just check that it only have one unique digit. Only have one unique digit. We just record and update the maxima. Yeah, that's the problem. This title is going to be linear. Okay, now this problem. Q4. Q2 is going to be, this problem is just, it's going to be, okay, this problem is count the number is equal to average of subtree, and subtree is include the root self. Okay, include the root node self. For example, say for this node, the subtree is 0, the sum of the number is going to be 1. We just calculate that if the root value is equal to the average value of the subtree. So what is the idea? Actually, you can use brute force approach because the range is 1000, and for each node we just track that, okay, how many number, and what is the sum under this node. This is a brute force approach, and let's take n squared. But if you think, if you do a lot of this problem, you can use post order. You use post order DFS to do that. How to do? Okay, we just recall two information. The first is the sum, and second is the number of nodes. And for left and right, we just try to first we calculate the left node and right node. For this, so we do it from the left. Yeah, we do it from the left. So we calculate the left and the right node, and we add about the sum and add about the number, and we just check that, okay, if this is the same to the root value, we add the answer, and after that we just pass the information to the root. For this node, we will get this 2 node information. So we don't need to traverse the node, because we just use the child information. We can easily to get the number of the sum in the subtree and the number of the nodes in the subtree. So this is the idea. Yeah. And for this problem, this problem is this is the count the number of tags, and actually you just think this is okay, I don't know how to say this is a keyboard or form keyboard, just 1 2 3 4 5 6 7 9. And this problem is going to be, you give it about the digit information, and you want to find how many distinct number of the tags that can be produced. So and the problem means that for the 2, if you press the B, you press the later, you will add the index of the node, index of the later. For example, if you add the later B, we will add 2 twice. If we add later is going to be C, we will add 2 3 times. So this is a problem. And now I give you the digit. Can you give me the number of the distinct laters that can be generated by this information? So What is the idea we can use dynamic programming? Because we just preprocess the digit length. For example, 2 maximum length is going to be 3. We just preprocess the length. Processing length of each digit, right? And now what do we do? Now suppose we have this information. Actually, we just check that. Okay, let's define it and use dynamic programming to do that. The numbers way so far here. Actually, it's not so far. It's from the right, from the so far to the end. Actually, it's the DP. And if you write the top-down approach, I just try to So for this digit, we know the length of maxima, and we just try to that. If continuous, this is continuous digit. If it's still the same, we can use we can plus A, or if we have 2 we plus B. If we have the 2 we plus C. For example, say we can plus A and we can plus we can plus B, because we have the 2 and we have the 2 we can plus C. So this is the idea. This is distinct. So we just move to the next transition and we recursive to call that. For example, 2 is going to be 2 can skip to the index to the next position I plus 1, or we still can skip to I plus 2, or we still can skip to I plus 3. That's the idea. And for this information, I plus 1 is still the same. For this information, we can still 2 can skip to I plus 1, I plus 2, and we just calculate until we reach the end. Yeah. That's the idea. And wait, if it's a single digit, why it cannot be wrong? Because we have the 1's digit here. Can add a resource to 1. Okay. Wait, I forgot to add. If I plus j is more than I need to care for this. Yeah, I think this may be overflow, but I'm not sure. But actually, I think this should be overflow. Yeah, this can be overflow. This can be overflow. So you need to add a condition to do that. So that's the idea. So the overall current complexity is going to be, the transition is at most 4, and we have the distinct index. So the time complexity is going to be linear. Yeah. Okay. This problem. Wait. Why? Wait. Is this a set, but I don't have a summation? Wait, I don't understand. I don't have a summation. Wait a moment. Wait. This is my network is dead, or I really don't have the why? What? Yeah, interesting. I can figure out that. Yeah. okay. Let's see the problem for. So for this problem, we need to find the valid parasite string path, and for the each position, we need to find a valid parasite is going to be the well form, or A and B is well form, is a valid parasite string, or we can have a cross well form. And you given about the matrix of the parasites of grid, you want to find if they have the valid parasite string path in this grid. So we can have each position, we have the two position. We can go into a right or go into down here. Now what is the idea? Idea is that we use dynamic programming, and the dynamic programming is defined as the current position and the score so far from the 0 index here. And now the transition is going to be, we can either go into the right or either going to down, and we just calculate the score. Okay, and we define the score is the left parasite, we will add a 1, and now negative parasite we will add 2. We will add -1. Yeah, so that's the idea. And we use the memoization, and what is kind complexity is going to be n product. Score is the n product, n plus n. So the kind complexity. Transition is going to be O1 here. So this is kind complexity. Yeah. Score. Yeah, because score is actually we only have the sum of this. This is still be the sum. This will still be the same. Only have 6. Only have 6. You can easily to figure out that the score maximum is going to be the n plus n. Yeah. And yeah, we just try to do that. We order for the two candidates to define it, to determine the DP. Yeah. But I don't understand what is. Oh, okay, finish. Okay. It's just today it's not a bad day, but actually, it's too slow. Don't understand this. Okay, that's my today's weekly contest.